Hello, okay. We're going to do one of the classic quadratics application questions. There's a few. One is involving projectiles, which we're not going to do, maybe in another example. But the other one is the fence problem. So we're looking at quadratics, and we're going to look at the fence problem. There's lots of variations on this theme. Essentially, it's looking at the importance of area given some properties of boundaries. I'm going to do sort of the classic example, but realise that there are a lot of similar questions which are just variants on a theme. So the problem is essentially this. You've got some paddock with maybe something like a river, and you've got a set length of fencing. So let's say we've got 150 metres of fencing that you've got to put against the river. Very classic. Really good starting point. Draw a diagram. Always draw a diagram. And then we've got to start looking at what sort of questions we can get asked. Often a question of this nature will give you some dimension of the enclosed area. Okay? Typically X. Be always careful if it's something else like W or L. Don't just plough ahead with X because that's what you've learned. Actually look at the particular question you're asked. A typical first question might be to give the area in terms of X. Okay, so it's referring to the enclosed area by the fence. And we might need to do a few steps. Sometimes you'll be walked through this in the question, other times you'll be expected to do a bit on your own. We need to realise that the total length of fence available is 150 metres. This side, this looks like a rectangle, or close enough. This side is also going to be X, no problems there. This side is got to be made of the remaining fence. So we've got 150 to start with, and we've taken away 2x. Okay, so we've got to realise, generally when we work out the area of a rectangle, it is usually length times width, times, and we know the width here is x, and we've just figured out that the length is 150. So you just sub those values in. That's usually enough for that sort of question. You may wish to expand. Make sure you do it correctly when you do it, because it would be a shame to do all that good work and lose it for something simple like forgetting to put the square or timesing both terms by the x. It's not a bad time to stop and think and just look at what you've come up with. Does it seem reasonable? And graphically, what is it going to look like? The coefficient of the x squared term is negative. So we've just got to be thinking that's a little marker for us, just reminding ourselves, even do a quick sketch somewhere, that we've got some sort of parabola that is reflected in the x-axis, okay? Or an unhappy face, which is the way to remember, it's negative. Okay. Another classic sort of question might be, is you're given an area and you have to find the dimensions, the value of x and the length that give that area. Okay, so you just substitute it into the formula you've just found. So we have that 2,800 equals 150x minus 2x squared. Do a little bit of rearranging. I'm going to rearrange it so it's 2x squared minus 150x plus 2,800 equals 0. Why have I done that? So it's in a form I recognise. I've got x squared term followed by an x term followed by a constant equals to 0. So now this is just solving a quadratic equation. Now we've got some big numbers. And hopefully you noticed that there is a common factor of 2, so we can instantly make it a little bit easier on ourselves. If we've got a CAS or something available, we could reach for it right now, but it's good to be able to do this by hand so you actually know what's going on. So we've got 75x plus hopefully 1400. Again, there's lots of ways you could approach this. The fail-safe is to always reach for the quadratic formula, but of course that's going to take you time and you've got some large numbers to work with. You could try completing the square, or you could hopefully see that I've rigged the question and it factorises nicely to x minus 35, x minus 40. And I'll leave that to you as an exercise to check. Alright, now we just use the null factor law. Okay, you don't have to write null factor, I'm just reminding you. Which is saying that this is true when either this whole term or this term is equal to 0. Okay, so we've got x minus 35. It could be when that equals to 0 and or when x minus 40 equals to 0. And that just leads us to the two values x equals 35 or x equals 40. Remember, if you're doing an application question and it involves units, check whether units should go in the answer. I thought I'd take an aside. That's typically what you'd get asked for that sort of question for part B, but I just wanted to think graphically what that's going to look like. If we think quickly about the graph, and I don't need that anymore, so we can take that off. Hopefully you see that it's quite a simple one to graph. Probably not all features at this point, but at least some of them. And this is a really useful time to reach for your CAS calculators. It may help you with this. But what we have, recognise we have a as a function, and we have x on the horizontal. We have a root at 75 and 0. You can go through and figure that out. And notice I'm actually going to put coloured in dots. It's not really sensible to this question to have negative area. 0 area, well, that's up to your interpretation, but I'm going to include it. And this is what we've got so far. Some sort of parabola. We don't have a huge amount of information, but how do we graphically represent this sort of solution? Well, let's say that 2,800 is around here, and we go across, it cuts at 2 points. Okay, so that means there are two solutions to this sort of question. And now we know that they are at 40 and at 35. Okay? Now, the final question is typically, and I might get rid of part B there, is we're interested in our available fence in creating the largest enclosed area we can. We want to get the best bang for our buck. So typical C would say maybe find the value or the width of x that gives the largest enclosed area. Okay, so how would we approach that? Well, this is where it's useful to have a quick but somewhat detailed sketch of our graph. We know that the largest area is the largest value of A we can get on our curve, which is going to be our turning point. Now you could go ahead and convert the equation you have into turning point form, but if you've done a quick sketch, or you've actually figured out some other points that are on the curve, there's a bit of a shortcut. We've got to remember that we have that parabolas are constructed along this symmetry of axes. And so that means this distance is the same as this distance. Or this distance, which I should have labelled before, 0, 0, is the same as this distance. So the x value of this axis lies on the midpoint between those 2 points. So we can find, and we can call that, say, xm or something. Xm is going to be, in this case, doesn't matter which one, I'm just going to go the easiest way, which is 75 plus 0 over 2. It's the midpoint. I neglected to say axis of symmetry is important because it passes through the turning point, which is the point we're interested in. So we get 75 over 2. Now, be really careful with the wording of these questions. Sometimes they ask give the largest area, sometimes find the x value, or give the dimensions. If it's asking you to give the dimension, you have found one dimension of your paddock. You need to find the length. Remember the diagram. If you found this, you found that this is 75 over 2. We don't know this yet, so you would just have to substitute that value in. That's 75 over 2. Okay? Which hopefully you see is going to be 75. To find the actual area enclosed, you would just substitute this value x. We might actually do this, 75 over 2, into our equation, which was 150 minus x squared, wasn't it?
2x squared is here.
Thank you. Alright, there's lots of ways we could simplify this up. I'm going to see that that is the same as 75 squared minus 75 squared over 2. It'll get easier, I promise. There's probably other shortcuts you could take at this point, but I like that you're left with 75 squared over 2. Don't be afraid to put a bracket around large numbers, just to remind yourself that it's the whole number, which I think is 5,600 and, let's just do the cheat, 25 it is, over 2. Again, if it's a question starting with units, check whether units should be in the answer, and I should have put some units up here. And that's how you approach a question like that.